Have you guys heard anything about you being invited to the institute? Because here in UP, the government has issued some notification saying that colleges should open now. Okay, so I'm not sure. Have you guys received anything on that line? Has anyone told you anything about it?
So actually, we had sports class yesterday. So Anuj sir said that we had no hope before July.
Acha. Okay. Okay. Because there was a circular or some notification that colleges should be opened, something like that. So I thought maybe the institute has some plans or anything. I guess the issue is they don't have the hostels ready. I went there on 26th of January, so I think the hostels are they're still probably not in the ready state. So this is one of the issues. They probably cannot call you straight away. I mean, I'm not sure. I'm just guessing. Maybe they are ready. This is what I heard that the hostels are not yet ready. Anyhow, okay. Let us let us wait for a while. Yeah, attendance is open, guys. So please. Was there a class from 9 to 10? I think yes, right? Okay, let's just wait a couple more minutes. So we have touched 50. I think 50 could be a good point to start with. So just a reminder, by the way, we are going to have a common lab tomorrow from 4:15 to 6:15. Okay. In fact, uh, I'll give the questions at 4 o'clock itself. You can submit up to 6:15. There is no issue. Okay. And it will be a common lab for uh, both the sections. Okay. Okay, so let's start, guys. Today's lecture is about the second part of file handling. So that was actually a kind of two-part lecture that was broken up into two parts. Actually, it was just one lecture. So we are going to discuss the second part of the lecture. I'm not sure how many people have watched the lecture, because in the other batch there was, I mean, I realized that very few people had watched the video in the other batch yesterday. So I'm just hoping that I was told that most of you watch these videos on Google Drive. So it's perfectly fine with me, because on the YouTube channel it's only 70 something views. So it's quite clear that people have not watched it, at least on YouTube. But I am assuming that some of you have at least watched it. So yeah, volunteers. Okay, Pranav is there. Anyone else? Open the sheet. Sahil is also there. Just a minute. Pranav, CSAI 10, right? Mm, this there. Okay. Sahil is CSAI 42. 42. Okay. Anyone else who would like to be a shepherd? It's a very small discussion actually. I mean, there's not much left in file handling, but we can also take questions from yesterday's lecture if you guys were not, if you had not seen the lecture till yesterday. So, okay, Ayusman, it is CS 24, right? Okay, just a minute. CS 24. Okay. Uh, three are fine. If anyone else would like to come in, you can tell me. Otherwise, we'll start. Uh, Sudeep, you probably have your mic on. Hmm. Okay, so I guess it's fine. We can start. Okay, let me share the screen. Okay, and for question number two, I can also open up the slides or something else if you guys want to. Okay, so it's up to you, but you can start now.
So may I try first question?
Yeah, go ahead.
Okay, okay. Then random access. Actually, the random access mean like if we open a file, we can randomly access any of the content. Like in the example which we have seen in search class, like there are five integers, and we can access any of the integers directly calling the function ftil or fseek. The ftil function is directly we can access the integers, any one of the integers, and fseek we can also change the any of the integers. And it is different from the sequential itself, by the way, that in sequential access we directly start from the 0 byte and then goes onward. Like, but in random access we directly access any of the integers by directly going to that particular byte.
So just a correction that basically for access you still have to use fseek, whether you're reading or writing. Ftell is more of a for information. Okay, so whether it is read or
Okay.
write, yeah, you use fseek only for both.
Okay.
Ftell is mostly to give you an idea that where exactly you are, because we have to do some arithmetic, right? We have to do some addition, subtraction to figure out how many bytes ahead or how many bytes backward should I go from the current position in order to access uh, the the required content. So ftell is used for that, and fseek can be used to actually take the position to a particular point in the file. And this basically will be the second question as well. But let's just take any queries if we have for the first question. So is it clear what is the difference between say randomly accessing some content within the file versus accessing the content in a sequence? Okay, the only idea is that where normally when you do not use something like fseek, you'll have to access the content in a sequential fashion, that you start from the first element in the list. And usually this is more appropriate for reading, but yes, it is also applicable to writing. But when you're accessing a file, especially for reading it, if you want to read a particular content in the file, you don't want to actually start from the beginning and then keep on reading everything. So then you would probably like to read something randomly. So in such cases, fseek is a good example. Fseek has a good utility.
Sir, I
And
got it wrong. Will you please tell me FTL, the function of FTL again?
yeah. So ftl is something like this. Ftl will tell you where exactly is the current file position right now. Okay, it doesn't change anything. So if you want to take the file position to some other location within the file, ftl cannot do it for you. Ftl is just a informative function. It will tell you that I have the file position, the file access position is currently at byte number x. Okay, the offset, it means that I have already read x bytes. It cannot change the position. Okay, it is just for information. If you want to change the position before reading or writing something, you will have to use fseek. So that is the difference. ftl is only for information. Fseek is for actually changing it.
Okay, sir. Thank you. I got it wrong. Thank you, sir.
It's okay. Any other queries, guys? So with that, we can actually move to the second question. If you guys want, I had some picture, I guess, which I can show it to you. But you can probably explain it first, and then we'll see.
Okay,
So
so I'll
FTL, as Sir said, is used to find the position of the file pointer right now with respect to uh, the start, whereas fseek uh, it is used to move the file pointer.
So does everyone understand the concept of a file access position? If you have a doubt with that, then please ask right now. If you still don't understand what do we mean by file access position, um, if you don't understand that, please ask. Otherwise, if that is clear, then yeah, then fseek and ftl are simple functions which will take you to a specific position. That's it.
Okay, so just in case, I'll give an example for FTL and FSeek. So imagine you have a notebook or something, and you're writing or reading from that notebook. So FSeek is like you need to move to some other page for writing or reading. In that case, you'll use FSeek. Let's say you want to move to page number 50, so you'll use FSeek 50. And F10 will tell you on which page you are right now. So for example, you're reading, or writing. After some time, you don't know on which page you are. So if you use F10, suppose you are on page number 5, so F10 will return 5, which is the page you are on. Yeah, so like this is analogy for this. Any questions? So, and in the third one, do you want to discuss struct packing or not?
No, not padding.
So could you move character after integer then?
Okay. Yeah. Okay. By the way, any queries on this? We have a there are two places where I have shown something related to file access position. I have shown it again for structures, but in the beginning I have shown it for char, int, double as well. If you want, I can share that image. If you guys have any queries. It is basically a particular byte offset. That is what fseek does, right? So you say if I have uh, let me just share the screen then only. Mm, Chrome tab. Okay, I hope you guys can see the screen. So it's like this, right? Let us say I have a total of 13 bytes written in my file. Some not 13 actually. This one is a simpler example. I think this is what double. Okay, this one is for
The
this.
struct is of
Huh,
seventh byte was struct.
yeah, this one actually is for the structure part that I have written later. Um, this is for the simple thing that let us say you start from here. So in the beginning, whenever you open your file access position is right before the first byte. Okay, right before the first byte. That is why I have said the byte offset is 0. Now, when you read uh, an integer, the byte offset goes to 4. You have read 4 bytes, and now it has been put here. Then let us say you read another character, it goes off by 1 again, and then you read a short, and then it goes off like this. So let's just say you just wanted to read this short. Okay, you did not really want to read this character or this integer. Okay, so then how will you do that? What you'll have to do is you'll have to put the file access position at this point and then read a short from here. So this is exactly what fseek can do for you. Fseek will actually take up this file access position to a particular point within the file, and then you can either read it or write it. That is the only thing that fseek is going to do for you. Okay, does it clarify the doubts? If you still have any questions, you can ask. Okay, so otherwise I'll just stop sharing it. And Pranav and Ayusman and Sahil, do you guys want me to keep this one? Let us say, uh, what is the size of that structure? Just a minute. Double
13.
8 13. So this one is not applicable. Uh, so you'll have to use some other example. Otherwise, I thought, yeah, yeah, actually, you can do it using this. There is a structure here. So instead of that structure, you can use this structure, and then you can answer the
So
question.
I think packing issues again. Care should be after short.
It's okay. Just
Okay,
assume.
ignore it. Yeah.
Just ignore it.
Okay,
Okay.
so if we are trying to write this struct called sample to the file, then we can see that int occupies, let's say, although it's platform independent, we assume that it is occupying 4 bytes of data. Char occupies 1 byte of data. Short occupies 2 bytes of data. So this is 4 plus 1 plus 2, which is 7 bytes.
Yeah.
So uh, let's say we are writing this. So we'll start with file access position at 0. So and then we'll go sequentially. So we'll first write the integer. So it will be like moving the pointer to 4 and writing the uh, data in that integer from 0 to 4. Then so the pointer will be moved to 4. Then we'll uh, write the character. This is just one wide. So we'll move the pointer from 4 to 5 and write character between 4 to 5. Then we'll write short, in which case it is 2 bytes long. So we'll write the 2 bytes and we'll move the pointer from 5 to 7. So yeah, this is writing. Yeah, so
Uh,
this is like moving to 4, moving to 7. Yeah.
this is like
And this is if we write one more struct, it will move. In the same way, it'll move from 7 to 14, just like we moved it from 0 to 7.
okay. Any queries on this? Yes, Sita. It just tells you the position. It doesn't change anything. That is right. So any queries on this? So the idea is that when you actually write a structure, the variables, the member variables of the structure are implicitly written to the file. You don't have to write those member variables individually. So you can do something like fwrite and ampersand s1, for example, instead of doing fwrite ampersand s1 in bracket dot I dot C dot something like this, right? You don't need to do that. If you have a structure variable and you write it using f, right? It will be written in some fashion. Okay, so the reason we have not discussed something known as structure padding is that the actual padding thing will not affect your read and write. It is something that is with the implementation. As long as you read and write in the same fashion using the same, as I said, right, binary format. It doesn't matter if there is any padding or there is no padding, if it is little endian or big endian, things like this, right? So again, don't worry much about what is a little endian thing and what is big endian. The idea is that as long as you use you read and write stuff in the in the forms of structure variables, everything will be fine. You can simply read a structure variable from a file, just like a simple integer, character, or float. And similarly, you can write a structure variable to a file without any problems. So this is the overall idea, that you don't have to write individual member variables. Structure variables can be written straight away and read straight away from the file. Any queries on this? Okay. So,
Sir,
any queries? I- if Someone had a query?
yes, sir. In Little Indian method,
Mhm.
sir. 1 minute, sir.
Let me just type then. I don't know if you guys, because we have time, uh, I can actually type Little Indian and Big Indian on Google so that you guys can see some examples. Little Indian, Big Indian. Uh, I think this one will be fine, right? Yeah. So let me share this screen. We have time. Actually, this is not something that I planned to discuss, but there are no questions, so let us discuss this. This is something that you will study anyhow in computer organization, but still, right? I mean, let's just have a look at it. I think this is a better option to check. Okay, or anyone. Okay, this one is also a good option to see. So can you guys see the screen?
Yes, sir.
So the concept of little endian versus big endian is something like this. When you're storing data, right? Let us say especially data that spans across multiple bytes. How do you store it in the memory? Okay, there are two options that you have. You can store the least significant byte first and the most significant byte next. When I say least significant and most significant, let me tell you what it means. In very simple terms, let us say you are trying to represent a number using some binary format, right? Just assume that the number is positive so that we don't have that two's complement and one's complement and sign magnitude issues. No, for positive numbers it is the same. So let's just say you want to represent 4 in 16 bytes, in 16 bits, not 2 bytes. So the binary representation of 4 is 0 1 0 0, right? So but if I want to represent it into 8 bits, one way to do it is simply add 4 zeros, right? It is the same as we do it with numbers, right? So if I want to represent 5 in 3 digits, how do I represent it? I write it like 0 0 5. So similarly, if I have, let us say, a number called 4, which whose binary representation is just 1 0 0, but I have to represent it in 8 bits, I will write it like 0 0 0 0 0 1 0 0, right? So basically, I simply added more zeros to the left. It doesn't make any difference. Similarly, if I want it to be represented in 16 bits, I will add 8 more zeros on the left, right? So now I have these 2 bytes, right? One byte is all zeros, the left one, it is all zeros, and in the right one, I have the first five characters from the first five bits from the left are 0, and then okay, let me just write it somewhere, otherwise you guys will get. So I'm just writing it here itself so that you can see. So what I want is I want binary representation of 4, and what I'm doing is I'm saying it is 100. The binary representation of 4 is 100. If I want to represent it in 4 bits, I write it like this: 0100. If I want to represent it in 8, I would write it like this. So this is now in in 8 bits. And if I want to represent it using 2 bytes, so this is another way. Okay, so this is 4 written in 2 bytes. Okay, so now you can see that basically I have to store these 2 bytes in memory. When I store it, I can either store this one first and this one and this one next. Okay, or I can store this one first and this one next. So this is what is known as big endian versus little endian. That if you have some information to store, this is I think only specific for integers, I guess. um, I'm not sure whether it is also there. It should be there for floating point numbers as well, mantis and exponent. But the idea is that you have to store multiple bytes to represent a particular value, and which what is the order in which you store it, whether you store this one first or this one first. So that is the whole idea of little endian or big endian. So big endian means store this one first and this one later, and little endian means store this one first and this one later. That is the only change, right? Now, to understand how will it affect your uh, your file handling, this is how it will affect it. Let us say you wrote 4 bytes of text, 4 bytes of data in a file. If you read and write the file on the same platform, on the same system, then it doesn't matter, then the endian thing doesn't matter, right? Because um, on one machine, this will be a standard. Okay, it's not like in some files it will be stored as little endian, and other files it will be stored as big endian. No, this is something that is a constant for a platform. Your platform, and when I say platform, it means usually your operating system and some lower level APIs. So this will be fixed for that. Okay, some lower level system calls or something like that. So if you are using the same platform, the actual endian thing will be the same. Okay, whether it will be big endian all the time or it will be little endian all the time. So as long as you are reading and writing data on the same system, this endianness doesn't matter, right? Because it is the same standard which is being followed. But this becomes a problem, for example, when you do something like socket programming. Socket programming means when you are sending this data over network. When you send, let us say, an integer over network, the other party, the receiver of your communication, should also know whether you are using big endian or little endian. If you want to if you want the integer to be properly interpreted, this endianness has to be clear. Then both of you should use the same endianness. So so this is the overall idea. Don't be too much worried about what little endian and big endian means. You can just assume that this is more about actually storing data at the last level, at the byte level. How do you store it? This is what is little endian and big endian. So uh, this was something I think that Sahil was trying to ask. Yes, Sahil, you can now ask your question. Sorry.
Yes, I cleared the thing.
Okay, okay. So any questions on this? This is not something that you are supposed to study right now. You will study about endianness when you study computer organization. But because we had time and there were no other queries, I just thought I'll tell you. Okay. So do we have any queries related to? Let me just stop sharing this. Do we have any queries related to file handling in general, out of the previous lecture as well as this lecture? Anything that is not clear? Or maybe most of you have not yet seen the lectures at all. Because I don't think it was such a simple concept that it will be clear so easily. So to me it appears as if most of the class has not seen the lectures. Well, anyhow, from my side, this basically concludes. Is there any question?
Yes, sir.
Yeah,
Sir,
go ahead.
first of all, we will use FTEL to know the position, and then we will use FC to go to our desired position, and
Yes.
then after that we will use FWrite and FRead to do the.
Yeah. Yes.
Okay, sir.
Yeah. So this is the I mean FTEL, most of the time FTEL is actually not required. I mean you'll if you have done your programming well, FTEL is pretty much a useless thing, because you alone, this is only the case where, because uh, FTEL, it is not easy to use FTEL. It is mostly a kind of decorative function only. Most of the time when you're reading or writing a file, you know exactly where the file pointer is, unless there is some kind of a multiple thread execution where one thread might be executing and using the same file position. And as I said, don't worry about what threads are. But unless you are having some kind of multi-threaded application, it doesn't matter, right? I mean, you will know exactly where your file pointer is, file access position is. But FTEL is just there. You can use it if you want. But what you will probably use more is fseek. Fseek is a uh, very useful function, and with the help of that, you can not only read specific data within the file. You can also uh, overwrite some data, and that is there in the slides. You can see the example where we overwrite certain stuff. uh, Actually, Kirti, it is padding, not we did not discuss it. It is padding. Okay, so I think if there are no other queries, then we can probably discuss padding. uh,
Sir, will you explain the homework part?
what was the homework? Let me check.
Sir, accessing structure variables individually.
Uh, Accessing structure.
Sir,
The
learning concept. Yes, sir.
homework part in 9.3 or 9.2?
So 9.3, sir. The
9.3. Let me open up 9.3, because I also forget. Just a minute. What did homework? Write another which shows the user all the cards and the logos. Ha. So this is exactly how view. If you go through the list example, this is
yes, sir.
what we did, right? In the list example, we basically asked the user what element of the list would you like to see, and then using that arithmetic, we positioned fseek at that particular position. Then we read that particular integer. We showed it to the user. We asked the user if you want to change the integer. The user said yes. Then we actually rewinded the position by one integer by 4 bytes, and then we just overwrote it. So the same thing has to be done, but now with structure variables. Okay, so there is a file that just has three structure variables written one after the other. Okay, that is what we do in that cars catalog or car catalog.c. So there are three structure variables written in a particular file. You ask the user, which car would you like to modify, one, two, or three. User says, let us say three. Then you use fseek and you go to a specific position, and then with the help of fseek, you can ask the user for the new values for the car, car's name, and all those things, right? Petrol or diesel, something like this. I don't remember what all things were there. But basically the details related to the car, and then you overwrite that particular structure variable. It is exactly the same as overwriting an integer. It's just that the size of thing will now become size of that particular structure rather than size of int. Anshul, we will have um, some 2 hours of problem discussion in the next week. So I think you guys have already picked up two problems, right? What were they? I forgot. Yesterday we discussed that these are the two programs we will discuss. We can also discuss one more, like that you just asked, right? We can discuss the code of any file handling program that you want. Okay, and we'll pick it up. Probably the list modifier program is the best program. It has almost all the concepts, right? uh, or list reader, something like this. So that we will do. Clock code is one. There was one more thing, right? I forgot. So you guys have already picked two programs, and let us also put Anshul's suggestion for a problem discussion. So we need some structure sorting. Okay, structure sorting. Got it. I think structure sorting part, the other batch has also asked for it. Um, uh no, Nehal, don't try to. Although it is possible, but it is not a good way to do that, because of structure padding, it becomes difficult to actually um, get actual address of member variable first, and it becomes, but it's not recommended that within a file you simply change the exact value of a particular member variable. It is better that the better way to do it is something like this: read that structure variable into a particular, read the bytes associated with that structure variable into an actual variable, let's say s1. Then modify some value, okay, let us say s1 dot x equal to something else, and then s1 back. Instead of s1 dot x, read the whole structure, then modify a particular value, and then write the whole structure back. That is the recommended way. Okay. um, so okay, so clock code is one. Structure sorting, I think even they wanted to discuss it. So uh, it's okay if you guys would like. I'll discuss it with you as well. But I thought maybe you guys should discuss different programs so that you have like essentially 4 hours of problem discussion. Okay, what is this? Size of I used ampersand. Uh, so Jay, essentially, this is this is how your f-write function expects the arguments. It expects them with in a call by reference mode, and rather than call by value. And the reason really is that you can either pass a single variable to fwrite or an array, right? So just for the sake of having a general thing, they have made it ampersand, right? That you have to pass the first argument by reference, and from there onwards, because if you pass it by reference, you are basically giving it a particular address in the memory, and then the third argument of this fwrite function, that basically tells us the uh, number of variables it should write, right? And so this is more of a, if you, the simple answer to your question is, this is just a call by reference. You are expected to send the first element, the actual variable to write, by reference, and that is why you have ampersand. Okay, that is the difference. It's not call by value. All other things are call by value. The first element is call by reference. Yes, it is fixed. It is always fixed, Kirti. In fact, whenever you want to call any library function, um, this was something that we discussed in the beginning as well, that when you want to call a particular library function, what are the things you need to know? Okay, so the first thing you need to know is, um, what in what header file will is it actually declared, right? So it could be things like stdio.h, stdlib.h, string.h, ctype.h, so on. So basically the first thing you need to know is where exactly is the prototype defined. The second thing you need to know is, what how does it prototype looks like what is the first parameter, what is the second parameter, what is the third parameter, because you have to pass it in exactly that order, you cannot change the order. And third thing you need to know is the return type, that what exactly is this particular function going to return you back. So for calling any library function, you have to know these three things. Then that is why we use that man pages, man something, and if you go to that page, you will get to know all these things. Okay, is there any other query that I missed? Padding. So any more questions? If we are, and this is like anything about functions, or otherwise we can discuss structure padding. It's again, it's something that is not really necessary for you to know as of now. It's something that is specific to C++. Um, uh, mm, so pick one. Shall I discuss clean stdin, or shall I discuss structure padding? What do you think? You guys can tell me. We have around 13 minutes of time. Okay, let me start with clean stdin first. Then we'll just see. Okay, let me open up that code. Mm, Can any one of you tell me one program where I have used clean stdin? In some week, I'll have to open it up. Week, which week it would be? 9.2 it is there? Acha, theek hai. Okay. Can you tell me the program name? Let be in list element modifier. It should be there, right? Element modifier. Okay. So let me share the screen. Just a minute. Share. Where is it? Can you guys see my screen now? Mm, Right. Okay. Okay. So let's just have a look at this. So what exactly is happening here? Um, So the first thing is that I am asking the user to give me the name of the file in which the list is stored, and I'm using fgets to take that input. Okay, then what happens? I go down. I basically say which element should I fetch for you. Then this is a scanf. So first I used a fgetis. Now I'm using fscan. I'm using scanf. Now after that I'm planning to take a single character input. Okay, so here what did I take as input? Here I took a complete string as input. It actually this might also run into a problem, but because this is the first input of this program, I don't need this clean stdin. If this fgets was, let us say, after this scanf, I may have been required to use clean std in there itself. But because the order is like this, that I'm using fgets first and then scanf, so I don't need it. So but anyhow, so basically what happens after this scanf, I'm supposed to take another input, and this is a single character input. Okay. Now what happens? I told you guys. Did I tell you guys yesterday, or I discussed it with some batch. I don't remember whether it was your batch or the other batch. But the idea is something like this. When you give input to a particular program, the input doesn't actually reach the program as soon as you type something. Okay, it doesn't straight away go to your program. The operating system has a mechanism. It is known as buffering. Okay, so what does buffering mean? There is an input buffer. Okay, there is a place somewhere in your RAM where whichever key you press, it gets stored there. Okay, and there are certain ways in which this buffer is then sent over. The content of this buffer is sent over to your program. Okay, the most common way to do that is by pressing enter. When you press enter, whatever you have typed till now, okay, that content, that the set of characters that you just typed, they are now sent over to your program as input. Okay, so let us just see what happens. First your program starts. Okay, and we reach here, f gets. So now I'm expecting the user to type a string. Okay, the name of the file. So let us say I typed list.bin. Okay, list.bin. Okay, as until now fget has not gotten a single character to parse. Okay, it is still waiting for user input. But after typing list.bin and pressing enter, the whole thing, list, list dot bin, as well as that slash n character that I just pressed, all of this gets sent to my program. And basically f gets is given this whole input in one go, that now process the way you want it to be. Okay, so now what does f gets do? F gets has a way to parse your input. It basically takes everything uh, as an input and send it to this particular string, this particular string, as long as it doesn't find a slash n. This is the property of fgets, that this is how this is fgets is different from scanf. A scanf will actually as soon as it sees a space, it assumes that the input is over for this particular variable. fgets, it doesn't do that. It will consider that the input is over only when it sees a slash n character. Okay, so when you typed list dot bin slash n, now fgets understands, okay, so the input is list dot bin, so that is taken off. Okay, that gets consumed. Okay, list dot bin gets consumed, and that gets stored in file underscore name. Also, fgets also has a weird property that it will append a slash n towards the end of your string. Okay, so this is why I have this particular statement, so that I just remove that slash n at the end. So anyhow, so this was not of interest to us. Then what happens? I go down, I take an integer input here. Now, as long as you are taking integers and doubles and char, no, not char, integers and doubles, um, that slash n input is not a worry, because um, scanf is expecting you to type an integer, even if it first encounters that leftover scanf, that leftover slash n which fgetes has left. That slash n gets ignored. Whatever you type after that, that will be processed by scanf, and it will be stored into index. Okay, so it will process that as an integer, and it will be processed. But then again, you entered some number in the some index of the list. Let us say you entered 3 or 4, and then again you pressed enter. So now that enter, that slash n keeps on getting left out in the buffer, in that input buffer. It's not really the input buffer of the OS, but basically whatever inputs your program were given, out of that, that slash n always gets ignored, right? Because your scanf will not use up the slash n. So then what happens? Let us say I do not have this clean stdin. and then I try to do this choice equal to getChar. So getChar takes a single character input. Okay, a single character input, not more than a single character. What happens is that slash n, which was left over by when you pressed enter after putting this index, that slash n gets picked up by the getChar, and then that slash n gets assigned to choice. So to what it will look like to you is, you will not even be asked about in fact, let me check if I can modify this program and show it to you here itself. uh, Let me use %t and do choice. Okay. And then let me for a moment just comment this out. But I also need the file. Do I have the file here? I have list.bin. Modifier. अच्छा ठीक है. So here's what is happening. As of now, your program is not getting any input. I am typing list.bin. Your program doesn't know anything about what I have typed till now. If I just do backspace and type something else, your program still doesn't know what I have typed. Okay. When will your program get this list dot bin when I press enter? Okay, so as soon as I pressed enter, your program got access to this input that I gave. Okay, now it says which element should I read. Let us say I type 4. I can type 45 or whatever I want, right? As of now, your program doesn't know what I have typed. It will come to know when I press another enter, and see what has happened. This printf statement, which said give me yes or no, it did not ask me for an input at all. Okay, and this 10 is printed. Now let me see what is 10. In fact, just stop sharing and let me show you the ASCII chart. Share screen, Chrome tab, ASCII chart. Okay, can you see this 10? What does it say? LF, line feed character. Okay, shall I show it this one maybe? uh, what is 10, guys? This is line feed. It is the same as your slash n. Okay, so what really happened here? Let me now go back to the program. So what happened was here, even though I expected the program to wait for a y or n, it did not wait for it. Why? Because the getChar function simply consumed the slash n, the last enter that I had pressed when I typed 29. Okay, so the 29 was consumed by scanf, but it actually left the slash n within my input area. Okay, and then that slash n got consumed by getChar, so it never really asked for an input from me. It simply said, yeah, this is your input. Does it make sense now? Now let us see what happens when okay, just a minute, when I modify this. uh, Now let me uncomment this. Okay, and let me comment this, and here let me put a printf here. Okay, now let us do this again. Okay, so now you can see that it expects me to type the y or n, right? Why? Because in the std in, it actually consumed that additional slash n that I had. Okay, so now my character input will go through. I just do an n. Okay, um, but do you guys understand now that this is the whole concept? This is the whole reason. And sorry, it's already 11 o'clock. So let me just close it now. So is the use of std in clear now? Segmentation fault, we'll have to see what you did. Okay, it should not give you any segmentation fault. This is what it should do. You can send me the code and the screenshot, and we'll check. Okay, but but it should not give you something like this. Yes, 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 that is right, Nehal. Slash n is something that is added by fkits. That slash n, the previous slash n remains in your buffer. To the best of my knowledge, this is the case. Because let me in fact open up the man page. Actually, the man pages on Mac are not really that great. So just a minute. Man f it's sorry guys, if you guys have a lecture, you can go ahead. I'll just finish this thing and then uh, so this is what it says. um, fgets, right? Fgets function reads at most one less than the number of characters specified by this. The reading stops when a new line character is found at the end of file or error. The new line, if any, is retained. If any characters are read and there is no error, so actually the max uh, max because this is a BSD thing, right? Their manuals are not that good. Just try to open it on Ubuntu and see what it says. Whether it can, or you can also try this. You can put your clean stdin function right after the fgets call and see what happens. Is it consuming some slash n or not? Okay, so we'll have a clarity over it. But the idea is that that fgets is going to you to add a slash n, whether it is the same slash n that was there in the input or it is something that is added by it. I think it is added by it, but I may be wrong. And again, these are all implementation details. It is possible that on some platform it is the same slash n, on some other platform it is another slash n. Okay, so it's a bit difficult, whether you'll have to check and see. Okay, thank you guys. This basically concludes our actual programming syllabus. There will be one more week, the last week, where I will talk about some advanced C concepts like preprocessor directive and bitwise operators, but they are specific to C. There is that is not really a part of programming in general. Whatever we had to cover for programming in general, it is done now. The some stream and stores them into buffer pointed by 2 by s. A new line is read. It is if a new line is read, it is stored into the buffer. Okay, so then I guess it is consuming the same slash n, because it says if a new line is read, it is stored into the buffer. So then yeah, then we have the answer. It actually consumes the slash n. Okay. So then it is clear. So basically, if you are using fgetters, you don't need to use std clean stdin. That is the idea. Okay. But there is no harm. Try out your clean stdin function. I just got it from some Stack Overflow answer. That was a very good answer. I actually give the credit to that person every time I use that function. There is the link of the Stack Overflow answer. So yeah, so from guys, we'll have the lab tomorrow at 4:15. Okay, bye everyone.